Hi guys, I'm standing down here at my creek today, and I thought today might be a good day to kind of hang out outside a little bit and talk about a topic that kind of unites both paleontology and astronomy. I'm not as good as you guys at making these little TikTok things, but we're going to do the best we can, and hopefully I'm actually in the frame here. But I thought we'd talk about tardigrades today. So tardigrade is actually Latin for slow walker. These are little animals, and they go by many names. Tardigrade is just one of them. Tardi and grade, meaning the slow walker or mover. And another name that they go by is the water bear, because they look like little bears when they walk. And we can oftentimes find them in water, so that kind of fits pretty well. One of their other names is a moss piglet, which I think is pretty cute. They are found in moss. If you're thinking about what size they might be, they're quite small. They're microscopic for the most part. Fully grown, these little animals are about a half a millimeter in size. So they're not very big. You could just maybe barely see one with the naked eye if you had good eyesight and it was fully grown. But there's lots of these. There's somewhere around 1,300 different species of tardigrades on the planet, and they are endemic. They are everywhere. You would be hard-pressed to find an environment where these little animals don't exist. We find them on sand dunes. We find them on the tops of mountains. We find them in Antarctica, at the bottom of the oceans, in hot springs, pretty much anywhere you could really imagine. Rainforests, Indiana, wherever you look, you're going to find these things. What's special about them? Kind of how are they strange? Well, these are some of the living fossils of the animal kingdom. They're related to some of the very first animals that ever walked on our planet. These things are, if you think back to our paleontology unit when we discussed the Cambrian period, which was the first period where we start really seeing life booming. Remember the Cambrian explosion. Life is still in the oceans, and I know that some of you had somebody's group, I can't remember who, had the animal called Aisha. That's spelled A-Y-S-H-E-A-I-A. A-Y-S-H-E-A-I-A. I have no idea if I'm even pronouncing that right, but if you remember having that one, you remember it was kind of a long, not very large, but more tubular shaped animal. Had all these tiny little feet with little claws on the ends. And if you look up a picture of that or remember what it looked like, you're going to be surprised to see just how closely that little guy resembles the tardigrade. So we think they date way back. They've survived all 5 mass extinctions on our planet, so they are tough little buggers. In fact, their ability to survive is really kind of unsurpassed in the animal kingdom. They can survive extreme pressures, both high and low, like very low air conditions, like complete deprivation of air altogether. They can survive radiation, like extreme radiation. They can survive dehydration. They can survive complete starvation, extreme temperatures. We're really not sure what they can't survive. Maybe not astronomy students. Usually we collect these, and my astronomy students attempt to kill them. So I know it's kind of terrible, but sometimes they succeed, which is kind of funny because these things can survive everything, right? But anyway, remember that their relatives are very ancient, like dating back 500 million years ago into the Cambrian. These things probably are related to some of the first things that did walk on land. They're really interesting little creatures. They're quite small. They tend to eat plant matter. They have a funny little snout that sticks out the front of their face, and they can stuff that into a cell. That's how small they are, and slurp out the nutrients. A lot of them eat bacteria. They just suck them up from the environment. So that's how small these guys are. They're bacteria eaters. As far as like gas exchange, they don't have lungs or anything like that. They absorb and release gases through all their surface area, like their entire skin. Everything around them kind of brings in gases and releases it, and that's how they can do respiration. Oh, other things about these little guys. They've got 8 legs. The first 3 pairs. So their 6 legs they use for walking, and then their last set that kind of hangs off the back kind of points behind them, and they use that to hold on to different objects in their environment, because usually they exist when there's water. So we're going to take a little walk here and see what we can find. Maybe we can locate a few of these guys, go on the great tardigrade hunt. We're going to take you for a walk. Turn this around a bit. Still going. There we are. Yep. Let me collect my materials here. So the other day I got bored and I decided to make a bridge across my creek here. So got a cool little bridge that goes right across my creek. This is kind of hard to do with the phone. My hands are full here. Ooh. Yeah, there we go. I'm gonna take a little hike in the woods here. I made myself a trail just so I could run in circles around my house because I got bored. So what we're looking for are places that will be easy to find these little tardigrades. Like I said, they're everywhere. They're virtually every environment on Earth. But that doesn't mean that they're in enough numbers that they're easy to catch. And we want to kind of boost our chances here. So we're going to walk along and look for some of their best environments as we go here. Gosh, it's a beautiful day out. Oops. There. Some ironwood trees here. Ooh. The birds are singing. There's a trillium. That's pretty. Oh, hey, look at this. Where else would a moss piglet like to live than maybe in some moss? So moss, of course, is a plant, right? And these little guys, boy, it's so steep here, I can't hold this together, like to live in the moss. So we're going to just go ahead and take a little bit of this moss off this rock. Moss is not the best place to find these, mostly because it's got so much dirt in it. They're in it, it's just hard to remove them from the dirt. So we're just going to put a little bit, maybe just one little clump of moss in my petri dish there. Got some other junk in there. There we go. All right, continue along, see what else we can find. Ah, here we go. Here's what we're looking for. Some more moss there. You can see growing on the side of this tree here is both some moss, which is the green stuff there, and the lighter colored green stuff is called lichen. And if you remember anything from biology class, lichen is both a fungus and an algae living together symbiotically. So it's like two creatures in one. It's some strange stuff, but it doesn't have as much dirt on it. So finding them on lichen is usually a lot easier to do. But I found a nice piece of it down here on the ground. Easier to take off of. Here's a dead branch from a tree. And we're just going to, oh, look at that lovely lichen there. Put a bunch of that in my petri dish here. Look at this good stuff. Oh yeah. There we go. A little bit more down here. This is some nice looking lichen. Not many people probably get excited about that like I do, but some pretty good looking stuff here. Almost full. A few more pieces. Starting to get a nice little patch there, right? There, that's probably enough. Whole dish is filled up. If you notice, I flipped it upside down because they're going to be on the surface, not so much underneath of it. And then we're going to put a little bit of water in this. But while we're here, let's talk really quick about how this relates to astronomy, because you're probably wondering that right now. So these little guys, these little water bears, can enter a state called a tun. T-U-N is the word. And they can literally suspend their metabolism for at least up to 30 years. So that's crazy if you think about it. So metabolism is the chemical processes that are going inside your body that basically are keeping you alive. So these things can go into a state of suspended animation where they're all but essentially dead. You add water to them and they basically resurrect into creatures again. It's really pretty astounding. Their tons look like little elongated seeds almost. But there's nothing going on inside there when the water bear forms a ton. And how this relates to space is that we've actually sent these creatures into space. In 2007, they spent, a whole batch of them spent 10 days in the perfect vacuum of space without the temperatures here on Earth. Without the pressures, exposed to all of the radiation of space, and they came back and most of the little buggers were alive, including the ones that weren't in tons. So it's pretty doggone impressive. How can they do that? Like, how did they develop that? Well, scientists think that one of the ways that they might have developed that is by surviving all those 5 extinctions. They basically developed the ability through natural selection to survive really extreme conditions like radiation, like lack of oxygen, like completely drying out, situations that happened in many of those mass extinctions. So it's really kind of cool that today they're one of the primary animals that we use to study life in space, is the humble little water bear that just can't die. So we're going to take this down to the creek, and oh, it's pretty steep. Gonna add a little bit of water into this. Whoa. I'm gonna try not to spill this. Oh boy. There we go. Okay. We're gonna add a little bit of water in here. Doesn't matter, it's creek water, there might be some water bears in it, right? Now we're just going to let that soak for a couple hours, and then we're going to come back and take a look in a microscope and see if there's anything that we can find in there. So, be back with you here in a second. All right, guys, we're back. I'm down in my garage now, and we're getting ready to take a look and see what we've got here in the little container with the water bears in it. It's been soaking for maybe about an hour or two, and hopefully that's long enough to have rehydrated any of them that happen to be in tons. They should hopefully be squirming around in there. So what I've got is my Petri dish here, and you can see all the lichen is nice and wet there. I'm going to give it a little bit of a shaky shake here, kind of try and knock those little bears free. They could be just about anywhere in there squirming around. It's hard to find them if they're still on the lichen. So we're going to get some of that lichen out of there, hopefully leaving a few bears behind. Yeah, come on. There we go. Quite a bit of it out of there. And now we'll stick this under the microscope and see what we've got. Okay, so I'm going to take this over to where I've got the microscope set up. Trying to be careful here. And get it on here. It's going to take me a minute, so I'm going to cut out of this because it takes a little bit to find these guys. You kind of have to know what you're looking for. And I'll cut back here in just a second. Okay, trying to do this here. I'm not sure how well this is going to work out. I've got one right in the center of the field of view. Oh, there we go. You can see the motion down there. There's a rotifer just right above him too that's kind of whipping its cilia and moving some water around. There's all kinds of stuff moving in here. There might be more than one that I see. It looks like there could be one in the upper left over there too. But there's definitely one in the center. I'm not sure how good you can see that. I've got it on as high of power as I can get it. We'll watch him for a second here. Maybe I can zoom in. Oh, wow. Yeah, there we go. How about that for the iPhone for the win there? See him right there? There's a water bear. Oh yeah, you can see the rotifer up above him too. Look at that. We'll just watch him for a second here. You can kind of, if you look very close, you'll see his stubby little legs that he's moving around there. He can kind of stretch himself out. Oh wow, that's cool. His tiny little legs, little water bear. Look at that.